Hello everyone, this week we are moving to this chapter focusing on state of matter and heating and cooling curve. For state of matter, we are going to focus on solid, liquid and gas. Remember, for solid, they vibrate and rotate at fixed position, and the solid particles have low energy. Since they have low energy, they will stay at the same position. And since they stay at the same position, they will be closely packed in orderly arrangement. And since the particles are close to each other, they can form strong forces with one another. As for liquid, they vibrate, they rotate, and they will move around. So because they have slightly higher energy than solid. And in this case, they will be less closely packed together and in a less orderly arrangement. But no matter what, they have strong force but weaker than solid. And the last one here is gas. As you know, gas vibrate, they rotate, and they move randomly at high speed. They are everywhere. They have super high energy, that's why they can move very fast. Alright, so in this case, they will be very far apart from each other because all of them are just moving randomly at high speed. So in this case, they will have weak force between the particles. Okay, you all must memorize the change in state of matter. The term from solid to liquid is melting, liquid to gas is boiling or evaporation, and then gas will deposit to form solid. Then from another way, liquid will freeze to form solid, solid sublime to become gas, and gas can condense into liquid. You must remember this because you will need this concept for the next part. So now we are going to focus on this thing called heating curve. We are heating a compound. And this curve comes with different stage, and you will realize the stage at BC and DE, they are constant. A very standard question they like to ask, they will ask, during the process, is your compound constantly receiving energy? Okay, you must remember, even though you see constant here, but as you are heating, your compound is always absorbing energy. For example, you are putting your finger above a fire. There is no way at some point you suddenly don't feel the heat. Now you need to understand why there is this constant. Okay, so imagine starting from a solid. From point A to B, when heating a solid, the temperature of the solid rises. Why? Because at this stage, your solid is receiving energy and it will vibrate more and more and more, and this vibration can give out energy until it reaches point B. At point B, take note, your particles, they all keep on vibrating. Until point B, they have received the sufficient amount of energy to break the bond between the solid particles. So, at point B, all of your solid particles, they slowly, one by one, to break the bonds between the particles to become liquid. Imagine you are taking ice out from your refrigerator. Your ice does not instantly become water. Okay, why? Because your ice, the solid particles, are slowly absorbing the energy to break the bond. So, layer by layer, your ice will form to become water. So at this stage, from B to C, all of your solid are slowly becoming liquid. So this is a mixture of solid and liquid. Until point C, basically all of your solid already transformed to become liquid. So at this stage, all of your liquid will absorb energy again, and you will see the increase in temperature. So as your liquid is being heated, again, it absorbs the energy, it vibrates stronger and stronger until it reaches point D. At D, they have sufficient energy to break the bond again. So they will break the bond and slowly, one by one, to become gas. So at here, again, energy is being absorbed to break the bond. This is the answer you must write in your exam. And again, if they ask you for the state at DE, the state will be liquid and gas coexist. So until they reach point E, basically all of your liquid particles have all changed to become gas. So from point E onwards, your gas exists and they will absorb the energy and vibrate more and more, and the temperature will keep on increasing, but your state will remain as gas. Okay, the opposite one will be your cooling curve. Cooling curve means temperature keep on decreasing and the state will change. From A to B to D, there's a standard constant line as well. So I'm going to use an example for liquid to solid. When the temperature of your liquid decreases, your liquid particles will vibrate slower and slower, and they come together. And when they come together, it slowly behave like a solid until it reaches point B. You guys must take note, Point B, the freezing point. Okay, so when it reaches point B, now they have released enough of energy to form solid. Take note, if your compound melts at 50 degrees Celsius, this compound will freeze at 50 degrees Celsius as well. Which means if this compound absorbs X amount of energy to form liquid, the liquid particles must release X amount of energy to form back to solid. Hence, in the exam, you must write the heat loss to form the bond is exactly the same as the heat absorbed to break bond. Okay, so at point B to C, both solid and liquid, they coexist. Once your particles reach point C, this solid will just remain as solid even though temperature keep on decreasing. Okay, so must take note of these two heating and cooling curve. Very standard questions. Alright, the next one will be Brownian motion. What is Brownian motion? Brownian motion is actually an observation of how smoke rises. When you look at smoke, they don't rise up vertical. They go in all directions and just rise into the air. Why? This is because you are actually observing the smoke particles which are bigger than the gas particles. Gas particles, remember, they are so small, but they move in high speed. So when the fast-moving gas particles collide onto your smoke particle from any random direction, your smoke will be just bombarded from side to side and changes direction but continue to move up. That's why you can see your movement of smoke look like a dragon just going up and disappear. Okay, so these are the important things you guys must remember for this part. Okay everyone, we have come to the end of this video. To learn more and get tips to score A, you may join my online lessons where I will share with you tricky questions asked in the exam and you can even get my free notes. See you soon, bye bye.